Hello, in this tutorial we'll be looking at straight line. We'll be considering the following subtopics. We are going to start from Cartesian coordinates. We'll look at distance between 2 points, angle between two lines, the midpoint of a line segment. We'll look at gradients and slopes, and also intersecting line. Before we continue, if you like this video, don't forget to like, share and subscribe for more on this. Thank you for coming to rolesacademy. To start with, let's look at the Cartesian coordinates. In specifying the position of a point in a plane, it is conveniently accomplished by referencing their distance from two perpendicular lines, which are called the x and y axis. Okay, we have a horizontal line and a vertical line. The horizontal line is called the x-axis, and the vertical line, which is this line, is called the y-axis. And now this is simply the Cartesian coordinates. We can have numbering here. This is the positive x-axis, this is the positive y-axis. To the down we have the negative y-axis, and to the left we have the negative x-axis. So let's try to number this. Since we are starting from the origin, let me redo that again. This is the origin, which is 0. We can have 1, 2, 3, 4, 5. And also here, which is the positive y-axis, we can have 1, 2, 3, 4, 5. Now to the negative y-axis, this is going to start from negative 1, negative 2, minus 3, minus 4, minus 5. And also negative x-axis, minus 1, minus 2, minus 3, and so on. The perpendicular distance from the y-axis, or simply put, the x-axis, is called the x-coordinate or abscissa, while the perpendicular distance from the x-axis is called the y-coordinate or ordinate. Let's represent that. The x-axis, whatever falls to the x-axis, is called the x-coordinate or abscissa, while the perpendicular distance, which is the y-axis, is called the y-coordinate or simply ordinate. The two coordinates can be paired. They can be put in a pair with the abscissa or the x-coordinates written first. For example, if you have a point A here in the Cartesian plane, so if you have to specify the position of this plane, we are going to write the x-axis first, then we write the y-axis. X-axis is the abscissa, while the y-axis is the ordinate. For example, if you have a point P here, this is going to be x and y. So let's try to put real numbers here. We can have a point A on the Cartesian plane with the point 2, 4. So to locate the point 2, 4 on the Cartesian plane, let's drop this off. We look for 2, which is from the abscissa, which is x-axis. This is x-axis and this is y-axis. So on x-axis, point A is on 2. So point A is on this line, but we don't know where it is on y-axis. So on y-axis, we have here that it is on 4. So if we trace 4 also, so we now have our position of point A to be here, and this is 2, 4. Another example, if you have a point B with the coordinates negative 3, 2. Negative 3, 2. So on x-axis, we have the negative 3, and on y-axis, we have the positive 2. So let's go back to our plane. On the x-axis, we have the negative 3, so we trace this up. And on the y-axis, we have 2, and we trace this. So this point, where these two line means, this is point B with coordinates negative 3, 2. Now the last one. What if we have a point C with coordinates negative 3, negative 3? Also, as we are doing before, we have the x-axis and the y-axis. So on x-axis, let's locate -3. Here we have -3 again. But since our y-axis is also negative, then we trace our line to the negative side of y-axis. So this negative x-axis, which is -3, and this is the negative y-axis, which is also -3. So we now have our point C at this point, which is -3, -3. And that is simply how we can locate a point on the Cartesian coordinates. Now let's move into straight line fully. How do we find the distance between 2 points? Assuming we're given 2 points with coordinates A to be x1, y1, and point B to be x2, y2. How do you find the distance between these 2 points? Let's get straight into that now. Let's assume we have a Cartesian coordinate again, with this as our y-axis and this as our x-axis. And we have the y-axis over here. Note that I'm not considering the negative axis here. So let's pick out some imaginary numbers. Here we have x1, here we have x2. And then let's put this as y1 and this as y2. So let's locate point A, which is A, x1, y1. So since we are referencing the x-axis first, so this is our x-axis and this is the y-axis. So we now have point A to be here with coordinate x1, y1. And also point B, which is x2, y2. So we are going to have this particular point as point B. So B with coordinates x2, y2. So how do we find the distance between point A and point B? Let's go back to Pythagoras. So if you complete this, we now have a right angled triangle. And note very well, this is our point y2, this is point y1, and this is x2, and we have x1. So how do we find this distance? Distance AB. From Cartesian coordinates, we know that distance between this y2 and point y1 is going to be y2 minus y1. And distance between point x2 and x1 is going to be x2 minus x1. So we can bring out the triangle to be in this form. Okay, we now have line AB, which is the distance that we are looking for, and we have here to be y2 minus y1, and then to be x2 minus x1 with our right angle triangle. If we look at Pythagoras theorem, we have hypotenuse square plus this is equal to opposite square plus adjacent square. And then we have our hypotenuse to be AB. We can choose any of these lines to be opposite and adjacent. Let's take this as point C. So we now have point B, point A, and point C. So in relating this formula with this triangle, we can have AB square equals to AC square plus BC square. And don't forget we are looking for AB. If you can find the AB, that will be the distance between point A and B. So here, AB square will now be equal to our AC, which is S2 minus X1. X2 minus X1 square plus BC, which is Y2 minus Y1 square. Taking the square root of this to cancel out the square in AB, we now have line AB to be equal to the square root of x2 minus x1 squared plus the square root of y2 minus y1 squared. So we have the distance between points A and B to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the formula for finding the distance between 2 points. I'm going to write that out again. If you have points A and B, or points P and Q, or any point you are considering in the question, if you have to find the distance between the 2 points, distance will then be the root of x2 minus x1 squared plus y2 minus y1 squared. And that's the formula for finding the distance between 2 points. Let's look at some examples. The question says, find the distance between the following pairs of points. The first one, we have point A and point B, with point A having the coordinates 5, 3, and point B having the coordinates 7, 5. This is the first one. You can go on and try to represent this on a Cartesian plane, but to save time, we are not going to do that in this tutorial. We are going to use our formula direct to find the distance between points A and B as we have in this question. So the first one is point A and B, with A having the coordinate 5, 3, and point B with B having the coordinate 7, 5. Here we can have that 5 is our x1, 3 is y1, 7 is x2, and 5 is y2. Applying the formula, we have the distance between AB to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So here we have the square root of our x2 from this question is 7 minus x1, which is 5 squared, plus y2, which is 5 minus y1, 3 squared. So here we have the square root of 7 minus 2. 7 minus 5 is 2 squared, plus 5 minus 3 is also 2 squared. So we are looking for the square root of 4 plus 4, which is 8. So we can leave the answer in short form depending on the question. So we can now say this equals to 4 times 2, and this equals to 2 root 2. So this is sort. You can check out our catalog to learn more about sort. So we have the distance between point A and point B, which is AB, to be equal to 2 root 2. The second question, we have point P and point Q, with point P with the coordinates -3, -2, and point Q with the coordinates 1, -4. As always, this is our x1, this y1, x2, and y2. So to apply the formula, we have the distance PQ to be equal to, I'm not going to write out the formula again. So here we have the x2 to be 1 minus 3, that's going to be plus 3, plus y2, which is -4 minus -2, that is plus 2 squared. So we have the square root of 4 squared plus -2 squared is also going to be 4. This is the square root of 16 plus the square root of 4, and which equals to the square root of 20. Also from sort, this can be equal to 2 root 5. So this will be the distance PQ, 2 root 5. So that is simply how we can find the distance between 2 points. You can go on and look for questions, check out our questions, and now you can use them in applying and solving the distance between 2 points. And after you do this, find the distance between these 2 points. You can post the answers in the comment section below. Between point C with coordinates -1, 3, and point D with coordinates 2, -7. So find the distance between these 2 points and post your answers in the comment section below. Looking at how we can find the midpoint of a line segment. Take for example, if you have a straight line, that is not a perfect straight line. Yes. We have point A and point B. So we can say this is the midpoint. This is just an imaginary midpoint as point C. So what if we have coordinates of this point? We have point A to be x, y, and also point B to be x2, y2. And we have this as a point C, which is the midpoint of point A and B. So how do we find the coordinates of C? We already have the coordinate of A to be x and y, and coordinate of B to be x2, y2. How do we find the coordinate of C? That's what we are going to be looking at now. And let's try to see the element of the proofs. Let's consider the Cartesian coordinates. We have the y-axis here, and we have the x-axis. This is the x-axis and y-axis. So given a point P and point Q, this is point P, so going straight to point Q with this point, and we have the midpoint of this line to be point R. So imaginarily, we take the coordinate of point P to be x1, y1. These are imaginary coordinates, and we are taking point Q to be x2, y2, and point R to be x, y. So how do we find the coordinates of R, which is x, y? Let's try to complete this by drawing out a right angle triangle. So we should understand that this point is x2 and this point is x1. So this particular point is y1 and this point over here is y2. So let's try to get the coordinates of R. So if you have its own traces like this, such as we are now having x here and we have y, we can say that this length equals to y2 minus y. So that is what we have here. The same thing as what we have here. So this is y2 minus y, and the other part, this can be y minus y1. Also, the same thing applicable to the x-axis. Here we are going to have x2 minus x, and over here we have x minus x1. Let's name this as S and this point as point T. If you look at this triangle, we can have that the inner triangle PRS is similar to the bigger triangle, which is the triangle PQT. So let's look at this very well. This triangle PRS is similar to triangle PQT. You can check more on similar triangles and how to approach them. Now, since they are similar, we can have that PR over RQ equals to PS over ST. Check again, this is PR, this is RQ, and PS, the horizontal part, and ST. Also, since R is the midpoint of P and Q, we can have that PR is the same as RQ. Similarly, PS is the same as ST. Since PS is the same as ST, let's go back to the triangle. This is PS and this is ST. Let's try to equate them. PS equals to x minus x1, right? And ST equals to x2 minus x. Collecting the lifetimes here, we are going to have x plus x equals to x1 plus x2. So we have 2x to be equal to x1 plus x2, which now leaves us with x to be equal to x1 plus x2 divided by 2. Similarly, we can have that y equals to y1 plus y2 divided by 2. And this is simply how we can find the coordinates of the midpoints of 2 points, as we have seen, and this is the proof. So if you are given 2 points A and B with specified coordinates, you can find the midpoint of these 2 points by taking the first x and the second y, which is x1 and x2, dividing it by 2, and also for the y-axis, y1 plus y2 divided by 2. Let's look at some examples. The question states, find the midpoint of the line joining the following pairs of points. In this question, we are going to find the coordinates of the midpoints. The first part, we have point A with coordinates 2, 4, and point B with coordinates 6, 12. So here we have our x1 and y1, x2 and y2. So to find the coordinates of the midpoint of line AB is going to be a point C. Let's imagine that it is point C. It's going to be point C with coordinates x, y. So let's look for our x and y. As we see from the previous slide, so x will be x1 plus x2 over 2, and y will be y1 plus y2 over 2. So x1 is 2, x2 is 6 divided by 2, and y1 is 4, y2 is 12 divided by 2. So our x now equals to 8 divided by 2, which is 4, and y equals to 16 divided by 2, which is 8. So the coordinate of the midpoint, which is point C, will be x, which is 4, y, which is 8. So this is the coordinate of the midpoint. The second part, we are looking at point P with coordinates m, 0, and point Q with coordinates 0, n. The same thing here, we have x1, y1, x2, and y2. So point x will be x1 plus x2 over 2, and point y will be y1 plus y2 over 2. But we have something here. We are not looking at numbers for x1 and also for y2. We can easily put whatever we have there. So we have x to be x1 to be m, and x2 to be 0 over 2, and y1 to be 0 plus y2 to be n over 2. And this equals to m over 2, which is x, and y, which equals to n over 2. So we can say the coordinates of the midpoint of the 2 points P and Q. Let's make it a point R, which has the coordinates m over 2, and for our y-axis n over 2. And this is how we can find the midpoint of the line joining a pairs of points. Gradient is simply how bent or how slopey a line is. Take for example, if you have a line that slants like this, you have another line like this, you have another line, you have this series of lines. The difference between these lines is how bent, or better still, how slopey they are. And this is simply what we look for when we calculate gradient. Let's clean this off and look at how we can calculate the gradient of a line. The gradient is simply defined as the increase in y over the increase in x. Looking at a Cartesian coordinate, where we have the x and the y-axis. If you have 2 points A and B, with a line joining them, such as this, so this is point x2, x1, sorry for that, y2, and we have point A to be x1, y1. So to join this, we now have a right angled, sorry for the line, we have a right angled triangle. You get that? Now we understand that this point is our x2 and the point A is x1. Also this point is y1 and the point here is our y2. So the increase in x over increase in y, let's put that down. The gradient will be increase in y over the increase in x. And how do we get the increase in x? We subtract y1 from y2. So this particular vertical line will now be y2 minus y1, and the horizontal line will be x2 minus x1. And that is simply the definition of gradient. So we now have the gradient of the line of line AB to be equal to y2 minus y1 over x2 minus x1. We can also refer to gradient as slope. So if you're asked to find the gradient or you are asked to find the slope, it's referring to the same thing. And we can do that by looking for the difference between y2 and y1, everything divided by the difference between x2 and x1, which is y2 minus y1 all over x2 minus x1. Let's look at some examples. But before we look at examples, let's bring back our Cartesian plane, where we have the x and the y-axis, and we have points A and point B, with A equal to x1, y1, and point B equal to x2, y2. So joining this as we did in the previous slide, we have this point to be y2 minus y1, and the other point to be x2 minus x1. So our gradient equal to y2 minus y1 over x2 minus x1. So if this line AB makes an angle with the positive x-axis, let's assume it makes an angle alpha. If you look for tan alpha is opposite over adjacent. And then you have the opposite to be y2 minus y1, adjacent to be x2 minus x1. We can see that tan alpha and gradient gives us the same thing. Tan alpha and gradient gives us the same thing. So we refer to alpha as the angle of slope. Simply the angle that the line makes with the positive x-axis, that is the angle of slope. So another representation of gradient is tan alpha. If you are given alpha, we can still get the gradient or slope by looking for the tan of the angle alpha. So to cap it all, I want you to note that gradient equal to change in y over change in x, and also gradient equals to tan alpha. And don't forget, alpha is the angle that the line makes with the positive x-axis. Let's look at the first example. We have the question which says find the gradient of the line joining point A, which has the coordinates 3, 2, and B, 7, 10, and the angle of slope of the line. We know that gradient equal to the increase in y over the increase in x, which is y2 minus y1 divided by x2 minus x1. And according to this question, we have 3 to be our x1, is x1, y1, and we have x2, y2. So let's go back. So y2 is now 10 minus 2 over x2, which is 7 minus 3. Over here we have 8 divided by 4, which is 2. So we now have gradient to be equals to 2. That's the first part of this question. The second part, the question says the angle of slope of the line, that is however, as we look at in the previous slide. So we know that tan alpha equal to gradient, and we're looking for alpha. So since we have already gotten our gradient to be equal to 2, we now have tan alpha to be equal to 2, and alpha equal to the tan to the inverse of 2. Here we have alpha to be equal to 63.43 degrees. This is how we can get the gradient and also the angle of slope of the line. This is another example, just like the one we have in the previous example. Find the gradient of the line joining A, -3, -5, and B, 4, -1, and the angle of slope of the line. We have gradient as usual to be y2 minus y1 over x2 minus x1. And then we have our y2 to be equal to -1 minus -5, and x2 to be 4 minus -3. So this is going to be equal to 4 divided by 7. This is the slope, 4 over 7. Let's just leave it like this. You can convert this to decimal form. So to look for the angle of slope of the line, we already know that tan alpha equal to gradient, we can say that tan alpha equal to 4 divided by 7. So alpha is tan inverse of 4 over 7. If you look for this, we are going to have our answer to be equal to 29.74 degrees. So 25.74 degrees is the angle of slope of the line. If two lines intersect, such as this, and we have to find the angle alpha between these two lines, let's assume that the slope of the first line here is m1 and the slope of the second line is m2. To find the angle alpha, we are going to be looking at the formula, which is tan alpha equals to m2 minus m1 over 1 plus m2 m1. This is just a quick recap of what we are going to be talking about. So we are going to derive this formula. Now let's look at a Cartesian plane. Here we have our Cartesian plane with the y and the x-axis. Let me redraw the x-axis. Okay, we have the x-axis here, and we have the y-axis. So I'm going to imagine two lines now that intersect. We have a line here, and we have and we have another one here. But to make it more clear, let me redraw the second line. It's not coming out clear. Okay, I think we have a good one here. And this is line A, B, this is line CD. So if you are looking for this alpha, which is the angle between these two lines, so we are naming this as alpha 1 and this as alpha 2. This as alpha, opposite angle equal, so we have alpha here, we also have alpha here. Just for some easy navigation, let's call this side P and this side R. So we are assuming that the gradient of AB equals to M1 and the gradient of CD equals to M2. Then from the formula we have that tan alpha equals to M1. This is going to be tan alpha 1. You know what? I'll just do this again. Let's rub this off. Let's consider line AB. Line AB makes an angle of alpha 1 with the positive x-axis. So we can get the slope of line AB by considering the formula for looking for gradient, which is tan alpha. Here we have alpha 1, which makes an angle with the positive x-axis. So this tan alpha 1 equals to M1. Since we are assuming that the gradient of line AB equals to M1. And also line CD makes an angle of alpha 2 with the positive x-axis. So we can say that tan alpha 2 equals to M2. Also from the rules of triangle, we know that alpha 2 equals to alpha 1 plus alpha. This is the exterior angle of a triangle. And then we are going to have that alpha equals to alpha 2 minus alpha 1. To continue the proof, let's take the tangent of both sides for this particular equation. So now let's take the tangent of both sides. We now have tan alpha equal to tan alpha 2 minus alpha 1. And from trigonometric ratio, if you have tan alpha 2 minus tan alpha 1, this is going to be tan alpha 2 minus tan alpha 1, everything divided by 1 plus tan alpha 2 multiplied by tan alpha 1. This is derived from trigonometric ratio. You can check out our catalog on trigonometric ratio and how we can derive this and how we can prove it. So we are going to have here to be tan alpha 2 is M2 minus tan alpha 1, which is M1, divided by 1 plus m2 m1, and that is the formula for finding the angle between these two points. Let me write that again. If I'm looking for tan angle alpha, which is the angle between two lines, this is going to be equal to m2, which is the gradient of the second line, minus m1, gradient of the first line, divided by 1 plus m2 m1. This is m2 times m1. Let's look at some examples to illustrate this point. One thing you have to note here is that we are taking the absolute value. So if you have tan alpha, it's going to be the absolute value of m2 minus m1 over 1 plus m2 m1. Please note that we are taking the absolute value of m2 minus m1 over 1 plus m2 m1, so there won't be negative cases. As an example, let's look at this question. Find the angle between lines AB and CD given the coordinates below. We have to find the angle between line AB and line CD. Let's write out our formula again. We know that if you are looking for alpha, which is the line between two, which is the angle between two lines, you're going to have tan alpha to be equal to the absolute value of m2 minus m1 over 1 plus m2 m1. Now we have gotten our formula. So what's the slope of AB and the slope of CD? Let's make m1 to be the slope of AB. And then for AB, we have the slope to be equal to y2 minus y1, which is 3 minus 1 over 4 minus 3, and this is 2 over 1, this is 2. The slope of CD to be m2, and this equals to 8 minus 6 over 7 minus 4, and this is 2 divided by 3. Now going back to the question, we're now going to have, let's draw a line, okay, tan alpha to be equal to the absolute value of m2, 2 over 3 minus m1, which is 2, over 1 plus 2 over 3 times 2. Here we're going to have tan alpha to be equal to 1. So alpha equal to the tan inverse of 1, and alpha equals to 45. So the angle between these two lines, AB and CD, equals to 45 degrees. We will be looking at some series of conditions. The first one we'll be looking at is the condition for parallelism, and the second one will be the condition for perpendicularity. For the first one, if two lines are parallel, for example, something like this, then we say that the angle between them is 0. The angle between two lines that are parallel is 0. We now have our alpha to be equal to 0, and tan 0 equals to 0. So going back to the formula for finding the angle between two lines, the formula is defined as tan alpha equals to the absolute value of m2 minus m1 over 1 plus m2 m1, where m2 and m1, they are the slope of these two lines. And now we now have our alpha to be equal to 0. So tan 0 equal to 0. We now have 0 equals to m2 minus m1 over 1 plus m2 m1. Here if you cross multiply, you're going to have 0 equals to m2 minus m1, and this can be written as m1 equals to m2, and this is the condition. So if two lines are parallel, then their slopes are equal. For two lines to be parallel, I take that again, m1 must be equal to m2. That is, the slope of the first one must be the slope of the second one. Let's look at the second condition, which is the condition for perpendicularity. If two lines are perpendicular, then the angle between them is 90 degrees. Therefore, we have a line AB perpendicular to the line CD. We now have the angle here to be 90 degrees. So going back to the formula for finding the angle between two lines, which is tan over equals to m2 minus m1 over 1 plus m2 m1. Here we now have two lines which are perpendicular, so theta equals to 90 degrees, and we have tan 90 degrees to be equals to infinity, which is undefined. So for this fraction m2 minus m1 over 1 plus m2 m1 to be undefined, then the denominator must be equal to 0. For example, if you have x divided by 0, this is undefined. 1 divided by 0, this is undefined. So the same thing here for m2 minus m1 over 1 plus m2 m1 to be equal to undefined, then 1 plus m2 m1 must be equal to 0. Hope you get that. Then 1 plus m2 m1 must be equal to 0. So we now have here to be m2 m1 equals to -1. And this is the condition for perpendicularity. If two lines are parallel, then the slope of the first one multiplied by the slope of the second one must be equal to -1. This gives us the condition for perpendicularity. We have an example here. Show whether AB is parallel or perpendicular to CD, given the coordinates below. A is 3,1, B is 4,3, C is 4,6, and 5 is 5,8. We have to check whether line AB is parallel or perpendicular to line CD. The first thing we have to do is to look for the slope of line AB. Then we look for the slope of line CD. Then we compare them whether they are parallel or they are perpendicular. To start with, let's look for the gradient or slope of line AB. And in line AB, I'm taking 1 to be the slope of line AB, y2 minus y1 over m2 minus, this is s2, x2 minus x1. We have our y1 to be equal to 3 minus 1. But before we do that, let me write out the coordinates of AB. For coordinate of AB, we have A to be equal to 3, 1, and B to be equal to 4, 3. So here we have our x1, y1, x2, y2. Going back to the formula, we now have y2 to be 3 minus y1, which is 1, over x2, which is 4, minus x1, which is 3. So this equals to 2 over 1, which is equals to 2. For the second, which is the gradient of CD, let's represent it by m2. And writing out the coordinates, we have the coordinate of C to be equal to 4, 6, and the coordinate of D, which equals to 5, 8. M2 equals to y2 again minus y1 over x2 minus x1. We now have y2 to be equal to what? This is x1, y1, x2, y2. Y2 is 8 minus 6, which is y1, over x2, which is 5 minus 4. And this is 2 over 1. So we now have 2. Since the gradient of AB equals to the gradient of CD, since we got the same thing here and here, we can say that line AB is parallel to line CD. We should remember that the condition for parallelism is M1 must be equal to M2. Here we now have M1, which equals to 2, and also M2, which equals to 2. Therefore, line AB is parallel to line CD. The second question we have here is this. The question states, if the line AB with coordinates A, -1, m, and B, 2, -3, is perpendicular to the line PQ, P5, 4, and Q6, 7, find the value of M. We have to find the value of M from this question. And we are given that line AB is perpendicular to line PQ. Therefore, if line AB is perpendicular to line PQ, and we are assuming that M1 is the gradient of AB, while M2 is the gradient of PQ. Therefore, M1 multiplied by M2 must be equal to -1, which is the condition for perpendicularity. For the first part, let's find M1. M1 equals to Y2 minus Y1 over X2 minus X1. And from this point, you have Y2 to be -3 minus M over X2, which is 2 minus -1. And this equals to -3 minus M over 3. The second part, which is the gradient of line PQ, this is M2 equals to Y2 minus Y1, just like we have it for M1. And this is X2 minus X1. We now have this. Y2 is 7 minus 4 all over 6 minus 5. And then we have 3 over 1, which equals to 3. I'm going to draw a line here. Now, going back to our condition, which is M1 multiplied by M2 must be equal to -1, since these two lines are perpendicular. Our M1 now is -3 minus M over 3 times M2, which is 3, must be equal to -1. This and this will cancel out. We now have -3 minus M equals to -1. And we have M is equal to -3 plus 1. M now equal to -2. And this is how we look for M. We have our M here to be equal to -2. In this section, we shall be looking at equation of a straight line. To simply put it, we can say that the equation of a straight line is the relationship that exists between the coordinates x and y of a variable point P in a Cartesian plane. There are various ways in which we can write out the equation of a straight line. We have up to 5. The first one we'll be looking at is the gradient intercept form. The gradient intercept form. And as our culture is in this tutorial, let's try to prove this also. If you have a Cartesian plane with our x axis and also y axis, if you have a straight line that passes through the y axis and has intercept over here at C, and this is line PQ. To find the gradient of this line, we need to complete the triangle by drawing a veined line over here. And we have that this is our x and this is our y. So to get the length of this side, we have is equals to y minus c, since we have c at the down part of y-axis. And for the x-axis, we have x minus 0, since we have this place to be the origin 0. Now to get the slope of this line, m will be the change in y over the change in x, and that's equals to y2 minus y1 over x2 minus x1. And in this case, we have our m, which equals to y2 is now y and y1 is c, over x2 is x minus x1 is 0. So leaving us with m equals to y minus c over x. Simplifying this, we have m x equals to y minus c, and we can have y equals to mx plus c. So that gives us the equation of the straight line, the first method of getting the equation of a straight line, y equals to mx plus c. Why do we call this gradient intercept form? Because we can use this method to get the equation of a straight line if you have the gradient, which is the m, and the intercept, which is the c. So if you are given the slope of a line and the intercept on the y-axis, we can use these two informations to get the equation of a straight line. That is why the first one is called the gradient intercept form. Let's look at the first example here. The question states, find the equation of the straight line with gradient 3 and intercept 2 on the y-axis. Remember that we have the formula for finding the equation of a straight line to be y equal to mx plus c. Here we have our gradient, which is 3, and intercept 2. This is gradient 3 and intercept 2. So to find the equation of the straight line, we consider the same equation, y equal to mx plus c. So this will be y equal to m now is down 3 multiplied by x plus c, which is intercept, which is 2. So this is y equal to 3x plus 2. And this is the equation of the straight line, y equal to 3x plus 2. How can we apply this? Or simply, what is the essence of getting the equation of the straight line? This equation simply means that if you know the variable x, you can look for the variable y, which is the x and y axis respectively. So, if we have an example, here we have the coordinates a point A with the coordinate 2 on the x-axis, and we have unknown on the y-axis, and we are given that the equation of the straight line is this. So we can simply substitute the value of x to be 2, and we solve for y. So here we have y equal to 3 times 2 plus 2, and this equals to 6 plus 2, that is 8. So we can write that the coordinate of A is 2, 8. And this is how we can apply the equation of a straight line. We have another question here. This is quite different from what we had in the previous slide. The question states, find the gradient and intercept of the line with equation y equal to 3x minus 4. We now have a given equation, which is the equation of the straight line, and we have to look for the slope, which is the intercept, and the slope, which is the gradient, and the intercept, which is c. If we relate this equation with the equation of straight line, which is y equal to mx plus c, we can do our basic relation, and we have that mx equal to 3x. The s will cancel out, and we have m equals to 3, and also c equals to negative 4. So this relates to this, this to this, and this to this. Now we can write out the equation or the gradient and intercept. So we have the gradient to be equal to 3 and the intercept which equals to negative 4. Similarly, this particular equation, which represents a straight line, the straight line has a slope 3 and intercept negative 4 on the y-axis. This is another question. In this question also, we are asked to find the gradient and intercepts of the line with equation 2y equals to negative 10x plus 2. Let me rewrite the equation. We have 2y equals to negative 10x plus 2. And we have the equation of the straight line to be y equal to mx plus 2 plus x plus c rather. If you look at these two equations, you see that they don't exactly look alike like what we had in the previous example. But what we can do to the first equation is to make it in the form of the general equation of a straight line. What we can do to equation 1, I'm taking this as equation 1, is to divide through by 2. If you divide equation 1 by 2, we are going to have 2y equals to negative 10x plus 2. Dividing everything by 2, we have dividing everything by 2, by 2, and by 2. We now have y equals to negative 5x plus 1. Now, this equation now looks like the equation of a straight line. And we can say, as we had in the previous tutorial, that m equals to negative 5 and c equals to 1. M is the gradient, while c is the intercept. The second form of the equation of the straight line is the gradient and 1 point form. If the line passes through a point, for example, we have a point Q to be x1, y1, and we also know the gradient m, we can consider the point P with coordinates x and y to get the equation of the straight line. Let's represent this on a Cartesian plane. We have our plane here, this is the x-axis, and we have our y-axis here. Now, given a particular line, this as our point Q, with coordinates x1, comma y1, and we have a point P with coordinates x, comma y. And we have already been given the intercept, or the gradient, which is m. So we can say that this is point, the length of this place is y minus y1, and this is x minus x1. Since this is x, this is x1, this is y1, and we have our y here. We already know that m is the gradient of this line. Therefore, we can say that m equal to change in y over change in s, which is in this case y minus y1 over x minus x1. And here we have it. This is another form of writing the equation of a straight line. To put this more clearly, we can say that y minus y1 equals to m to bracket x minus x1. And this is the method for getting the equation of a straight line, which is the second method. Let's look at some examples. Find the equation of a straight line of slope 3 if it passes through the point 3, negative 2. This is an example of what we looked at in the previous slide. We are given the slope, which is the gradient, and also a point, and we have to find the equation of a straight line. The formula we looked at was y minus y1 equals to m to bracket x minus x1 as the formula for finding the equation of a straight line, where we have one gradient and one point. From this point, we have that this is x1 and this is y1. We can now substitute x1 and y1 into the equation to have y minus y1, which is negative 2, equals to m. Our m now is 3 into brackets x minus x1, which is 3. Then we have y plus 2 equals to 3x minus 9. And to collect like terms, we have y equal to 3x minus 9 minus 2. And this is y equals to 3x minus 11. This is the equation of the straight line. Y equals to 3x minus 11. To put it simply, this is how we can find the equation of a straight line, where we have one gradient and one point. Remember, this is the formula. The third form we'll be looking at is the 2-point form. We are not going to be drawing the Cartesian plane for this form, but let's go back to the previous form, which is the form where we have one gradient and one point. We wrote out that the formula for finding the equation of the straight line is m equals to y minus y1 over x minus x1. But now in 2-point form, we're given 2 points, point A and point B. We are imagining point A as the coordinate x1, y1, and point B as the coordinate x2, y2. How we can write out the formula for finding the equation of this type of form? We can simply replace m, which is the slope, with the original definition for slope, which is m equals to y2 minus y1 over x2 minus x1. So this now leaves us with y2 minus y1 over x2 minus x1 equals to y minus y1 over x minus x1. And this is the third formula for finding the equation of a straight line. Don't forget, here we are considering the form in which we have 2 points, the point A and point B, with given coordinates x1, y1, x2, y2. We have an example here. Find the equation of a straight line which passes through the point A with coordinates 3, negative 2, and point B 4, 6. We are going to use the formula y2 minus y1 over x2 minus x1 equals to y minus y1 over x minus x1. Then we have our 3 to be x1, and this is y1, x2, and y2. Substituting x1, y1, x2, y2 into this equation, we are going to have y2, which is 6, minus y1, which is negative 2, over x2, which is 4 minus 3, equals to y minus y1 negative 2 over x minus x1 3. We now have 8 divided by 1 equals to y plus 2 over x minus 3. Let me draw a line here. To finish this up, we have 8 into brackets x minus 3 equal to y plus 2. We now have 8x minus 24 equals to y plus 2. Collecting the like terms, we have y equal to 8x minus 24 minus 2, and we have y equal to 8x minus 26. And this is the equation of the straight line. Y equal to 8x minus 26. What I want you to note here is that we use this formula in the case where we have 2 points. You can see that we are not given the gradient or intercept. We only have 2 points, point A and point B. So you can still use this formula to get the equation of the straight line. The last form we'll be looking at in this tutorial is the perpendicular distance form. If you have a straight line, define that a perpendicular distance P from the origin and the perpendicular distance makes an angle of alpha with the x-axis. Let's represent this. If you have a straight line such as this, and you have a perpendicular distance from the origin 0, and the distance, the perpendicular line, makes an angle of alpha with the positive x-axis, we can define the equation of the straight line to be P equals to x cos alpha plus y sine alpha. Take note of this. P equals to x cos alpha plus y sine alpha. This is how we can define the equation of a straight line, which has a perpendicular line from the origin, and the perpendicular line makes an angle alpha with the positive x-axis. Let's look at an example. The equation states that a straight line has a perpendicular distance from the origin to be of length 2 units at an angle 30 degrees to the positive x-axis. Find the equation of the straight line. Before you find the equation of the straight line, I want us to draw this and visualize it. So to have something like this, we have the x-axis and y-axis. This is a straight line, and we have a perpendicular distance from the origin, which is of length 2 units. And the perpendicular distance makes an angle of 30 degrees with the positive x-axis. Now, using the formula that we looked at in the previous slide, we have P equal to x cos alpha plus y sine alpha, where we have our P to be the length of the perpendicular distance. So this now equal to 2 equal to x cos 30 plus y sine 30, and this is 2 equals to x multiplied by 23 over 2, that is cos 30, plus y multiplied by 1 over 2, that is sine 30. We now have 2 equals to root 3 over 2 x plus y over 2. You can choose to leave our answer like this, or we can extend by multiplying through by 2. This is Miscellaneous, so let me change. If you multiply through by 2, we are going to have 4 equals to root 3x plus y. We can also leave the answer like this. I have some other examples I want us to consider here. This is the first one. It says that find the equation of a straight line which passes through the point 2, 4 and is perpendicular to the line 2x minus 4y plus 3 equals to 0. To analyze this question, we're given a point, which is the point 2, 4, and we're also given a line which is perpendicular to the line we are going to look for the equation of. Let me write out the equation of the line. We have 2x minus 4y plus 3 equals to 0. Note that if two lines are perpendicular, then the gradient of the first and the second one, if you multiply the gradient of the first one and the second line, it must be equal to -1. Take note of this. If two lines are perpendicular, then multiplying the gradient, we must have answer -1. So let's write this equation in the form of the equation of a straight line, which is y equal to mx plus c. And here we have -4y equals to -2x minus 3. I'm writing this in the form of this. Dividing through by 4, we have over 4 over 4 over 4. So here we have 4y equals to -2 dividing 2 by -4. -2 over -4x minus 3 over -4. This will cancel out. Now I have y equal to 1 over 2x minus 3 over -4. Considering this equation and this, if you compare these two equations, we have that m equals to 1 over 2. That is, we compare these two equations, the general equation of a straight line and what we derived here. We have y to be equal to y, mx to be equal to 1 over 2x, and c to be equal to -3 over -4. So we now have our m to be equal to 1 over 2. So to continue, we already got the slope of 1, which is m1. I'm taking that as m1 and m2 to be what we are looking for. So m1 is 1 over 2. That's the slope of the first line that we're given, multiplied by the slope of the line we are looking for. Since the two of them are perpendicular, then the solution must be equal to -1. We now have m2 to be equal to -2. Therefore, the slope of the line we are looking for is -2. Take note, we have gotten two ints here. We have a point and a gradient. Now we are going to use the formula of the form where we have 1 point and 1 gradient, which is m equal to y minus y1 over x minus x1. This was the second equation of a straight line that we looked at. And to apply this formula now, we have our m to be equal to -2 equal to y minus y1. y1 is 4 over x minus x1, which is 2. Crossing out and cross multiplication, we have -2 to bracket x minus 2 equal to y minus 4. This is -2x plus 4 equal to y minus 4. And this is y equal to -2x plus 4 plus 4. And this is y equal to -2x plus 8. And that is the equation of the line. Y equal to -2x plus 8. That is the equation of the line we are looking for. What you have to note here is that we are given the equation of a line which is perpendicular to the line we are looking for. And the slope, if two lines are perpendicular, the slope of the first one multiplied by the slope of the second one must be equal to 0. If it is parallel, if they are parallel, then the slope of the first one must be equal to the slope of the second one. This is the second example. Find the equation of a straight line which passes through the point 2, 4 and is parallel to the line 3x minus 5y plus 2. Just like we have in the previous example, which is perpendicular to the line, here we have parallel to the line. From condition of parallelism, if two lines are parallel, then the gradient of the first one must be the gradient of the second one, which is m1 must be equal to m2. But first, let's look for the slope of the line that we're given. We have 3x minus 5y plus 2 equals to 0. If you write this equation in the form of the general equation of a straight line, which is y equal to mx plus c, we are going to have -5y equals to -3x minus 2. Dividing through by -5, we have y equal to 3 over 5x minus 2 over -5. So therefore we have m to be equal to 3 over 5. this is our m1, which equals to 3 over 5. Since the condition is that m1 must be equal to m2, then the equation of the straight line that we're looking for, the slope m2 must also be equal to 3 over 5. Here we have a slope, which is the gradient, and also a point. We can now have the equation of the straight line to be m equals to y minus y1 over x minus x1. As I said before, this is the second form. We have m3 over 5 equal to y minus 4 all over x minus 2. Let's put on the line here. Now I have 3 bracket 5 or x minus 2 equal to 5 bracket y minus 4. This is 3x minus 6 equal to 5y minus 20. Collecting like terms here, we have 3x minus 5y minus 6 plus 20 equals to 0. And this is 3x minus 5y plus 14 equal to 0. And here we have the equation of the straight line. 3x minus 5y plus 14 equals to 0. To round off this tutorial, we'll look at one more section, which is intersecting lines. If we are to find the point of intersection of two lines that intersect, what we do is to solve simultaneously the two equations of the lines that intersect. Here we have a question which says find the point of intersection of the lines 2x plus y equals to 4 and x plus y equals to 3. What we have to do here is to solve the two equations simultaneously. The first equation is 2x plus y equals to 4. This is equation 1. And the second equation, x plus y equals to 3. Equation 2. From equation 2, we can have that y equals to 3 minus x. Let's name this equation 3. Then if we substitute y to be 3 minus x in equation 1, we are going to have from equation 1 that 2x plus y is now 3 minus x equals to 4. And this is 2x minus x equal to 4 minus 3. And then we have x to be equal to 1. Then from equation 3, we have y equal to 3 minus x. And this is y equal to 3 minus x, which is 1. And we have our y to be equal to 2. So we have point y equal to 2 and point x equals to 1. So the coordinate of the point of intersection of these two lines is at the point, maybe have 1, 2. Again, these two lines intersect at the point 1, 2. And that is simply how we can find the point of intersection of two lines that intersect. Don't forget, simply solve the equations simultaneously. To simply get the intercept on the y and x axis, for x axis, we substitute y to be 0 and solve for x. And for y axis, we substitute x to be 0 and solve for y. The first one is intercept on the x axis. For this equation, let's get the intercept on the x-axis. How do we get that? We make y to be equal to 0. From the equation, we have x plus 3y minus 6 equals to 0. If we put y to be 0, we have x plus 0 minus 6 equals to 0, which now leaves us with x equal to 6. And then the intercept on the x-axis will be 6, 0. Since we are writing the x-axis first, this is x and this is y that we put at 0. Then the second one, which is intercept on the y-axis. To get the intercept on the y-axis, simply substitute x to be equal to 0 and solve for y. And from this equation, we are going to have 0 plus 3y minus 6 equals 0. And here we have y equal to 6 divided by 3, and this equals to 2. Therefore, we have the intercept on the y-axis to be x0, 2, which is the y-axis. And that is very simple, as simple as that, how you can look for the intercepts on the x and y-axis of a given line. That is it. We have come to the end of this tutorial. But before we look at the exercises, let's consider the applications of straight line. In applying straight line, the list is vast and enormous, but I have 4 here, which is the first one: measurement, drawing, physics, and determination of law. In these areas, straight line, they are widely used almost every day. Even in our own day-to-day activities in business, marketing, driving, and some other things that involve calculation, we use straight line almost every day. The third one, which is the determination of law. If you can plot a graph, from that graph, you can use it to determine a relation or a formula guiding the graph. Therefore, this can be a law. You can apply it in your own calculations and wherever you need them. We have the exercises here. Check this out and feel free to post your answers in the comment section below.